Yes, thank you very much. I'm really happy to be here as an external speaker. And is this the right direction? Yes. So I want to tell you today the fun story how we became famous with beer. And by we I mean our working group that I'm in, and Matti, he's also here today. And I think this is an amazing story to I don't know to cheer with, and it's about this paper on the popping sound and liquid sloshing when opening a beer bottle. Okay, what is this paper about? So first, I want to tell you exactly what I am usually doing, so that you don't think I'm a weird scientist. So usually I'm doing serious stuff. So this is cavitation bubbles. So on the left, you see experiments, 4 frames of experiments, and on the right, you see a simulation. On the left, top left, you see that a laser beam is focused into water. The laser beam lasts for 10 nanoseconds, and it's very high in intensity. That's why past the focus, you don't see light anymore. It's all absorbed in the focus. And there's a plasma generated, and then there is a bubble afterwards. And I observed this bubble with high-speed photography, like up to millions of pictures per second, to see what's actually happening there. And over the past 10 years, my colleagues and I, we developed a code to simulate such a bubble. And that's what you see on the right-hand side. You see the shock wave that's emitted from the expansion of that bubble. And it's like 100 bars. And on the right, you see the velocity of that bubble that's like 100 meters per second. So it's very extreme. And what I do as a hobby is beer brewing. And by chance, I have some buddies in KWS. And that's also how I got here. You see here me on the left graining the malt, and you see the kettle where the beers, the wort that is going to become beer is in. And here you see on the, I don't have a pointer. Anyways, you see here one excerpt that I did last year. I called it Gölsch because it's not a Kölsch, it's made in Göttingen. And here we also have a logo, the Göttinger Bier Kollektiv, and that was founded by Stefan Meldau, who also brought me here today. And I got the nickname Dr. Plop, and you will see in the course of this presentation why that is the case. And now I'm interested whether I can start this video by clicking. Oh, yes. So usually you get this maybe with champagne, but you can also get this with self-made beer. And because I'm a fluid mechanics physicist, I was really interested in what actually happens when I open such a bottle. And here you see the whole working group in the lab, and I have to say this is the only occasion in my whole career where the whole working group was together in the lab at the same time. It was even so much fun that the absent Iranian colleague here in the front also participated. And you see me opening a bottle, illuminated with the high-speed camera here. And you see Matti checking out the videos. You see my boss and also our guest professor from Japan. And they all participated, and of course the photographer. And on the right-hand side, you see a frame of the high-speed video exactly in the moment when the cap lifts off. And because the beer didn't taste well, it was sacrificed for science. So, and by chance, I put it into transparent bottles, which was actually very good for science because you can illuminate through and see what happens inside. And let's see this in 12 times slow motion with sound. So you see the cap completely lifted off. That is because I used to overcharge my bottles with CO2. But this is only 300 frames per second, so not really fast. Let's see it with 7,500 frames per second. And before I start the video, I will explain to you what you will see. On the right-hand side, you see a simulation that was taking the code that we usually use for serious science, we were able to simulate that bottle. And in the moment where the cap lifts off, you see that the velocity of the gas is like 380 meters per second. So that's supersonic. That's like that only can do jets. And when you look closely to the video that is now going to be played, you will find 5 things. One is this condensation cloud when the gas expands out of the bottle. 2, you will see small particles ejected from the bottle. That's actually ice, because for a very short moment you will have minus 50 degrees Celsius. And then, when you pay close attention in the neck of the bottle, you see a vibration. And that's the core thing of the paper, and that I think was actually found by Matti. And afterwards, there is a sloshing in the bottle, and also bubbles nucleate. This is one frame of the video, and when you take one row of pixels out of this video for each frame and you stack them together, you get a streak image. So in this way you have time encoded on the x-axis. This is milliseconds, and on the y-axis, well, this is the pixel row. So you see the cap lifting off, and you see some spikes here. It's magnified here. You see some spikes. And that's actually the cloud that swings in the bottle. And the purple overlay here is the recording with the microphone that we had. And you find a perfect correlation between the recording and those spikes. And when you actually listen to the popping sound, you don't notice it. It sounds like an explosion. You all know it from champagne. But when you look at the spectrum, you get a clear peak at 800 hertz. So it's actually pretty tonal. It's not an explosion. So this was fascinating to me, and also to everyone that has a little bit of knowledge of acoustics, because you expect an explosion like, but this is actually like you say ah, but for 70 milliseconds. And then my boss looked at the amplitude of the swinging cloud, and then with physical laws you can deduce how loud it is, and it was actually 180 decibels, which means it's louder than the turbine of an airplane. And this is important for later on, I will tell you. And here is already a quote from Flens, so you kind of know where this is going. Flens said, "Oh, we didn't know we manufactured so many turbines." And here is something to show you that we could reproduce this whole thing with the numerics. So on the right hand top, you have the experimental spectra from different bottles. And on the top right, you have spectra from the numerics, which look pretty much the same. And here you have the simulation of a bubble, of a bottle, and the sound emission, and the overlay of the experimental recording and the numerical recording. So all this slide is just to show you that we actually did science on that, and it matches pretty well. And then, you had to write the paper, and it was close to Christmas. The deadline was on the 20th of December, and there were, maybe some of you know, when you have to write a paper and there is a deadline, you have to work hard and you have to do night shifts. And then I thought, okay, you shouldn't make your hobby your profession. It kills your hobby. And I kept saying this to colleagues, but today I would say, if you make your hobby your profession, the world would like it too. And this is maybe one of the takeaways from these slides, because what happened was actually that the journal that we submitted to, they would like to make it a feature paper, so a standing out paper. And in all my 10 years past career, I never got a feature paper with serious science. I mean, this is serious science, not to say, but This was already a reward for all these night shifts, but then I got a mail from the DPA, the German press agency, saying, "Oh, can we have a little call?" And I thought, okay, this is going to become interesting. And it was 10 minutes, not more, and it was well invested 10 minutes because one night, and then this happened. So maybe you have actually heard of it. So on the March 17th, we were famous in Germany, Austria, New York, Netherlands, and Switzerland. And you see quite some famous logos here, right? Apart from the Göttinger Tageblatt and some other local newspapers, there is also Spiegel, Stern, Welt, Geo, ARD, Deutschlandfunk, BR 24. They were the first. They reported about it at 6 a.m. So that's only Bavarians can do. And if I am able to click on this little loudspeaker or someone that's close to the bottom right, the SWR 3, then you can listen to some.
Kaum ein Geräusch kann so durstig machen wie dieses. Bei Dr. Max Koch vom 3. Physikalischen Institut der Uni Göttingen hat es vor allem den Wissensdurst geweckt. Er wollte nämlich wissen, was wissenschaftlich in der Flasche und am Bügelverschluss abgeht, in dem Moment, in dem es plopp macht. Und das hat uns natürlich auch interessiert hier in SWR 3 Move.
So, this was German. For those who understood, this was just the beginning of one of these radio shows. My phone rang like hourly. It was so incredible to become famous overnight. I don't know if anyone ever experienced that, but it was incredible actually. And now I'm very happy that you cannot vote for me because it would be totally unfair because
Kaum ein
sorry, one slide in between. The uni just last week agreed to pay the $3,500 open access fee, so you can actually get the paper now if you scan the QR code. It's open access. That was actually good because this is not a voting QR code, so this is to get to the gist of it. And now when all mobiles are down, I will tell you now why it's good not to vote for me, because I don't know the English word bestechen. Because we brewed beer for you. Because Stefan, he founded this Göttinger Beer Kollektiv, and there you already see some famous faces that have spoken today, and we brewed a KWS beer for you. You can only drink it today here. You can not buy it anywhere else because it's made with special ingredients, with rye malt and sugar beet flour, and some Crew hops. And if that's not enough, we have an alternative that's a pale ale from the barrel. And you also in this kettle there was the beer that we served today, and Professor G.J. Chai joined us for the brewing, so it was a special event. And we also have a very nice logo for it. It was drawn by Boglaka Barati from here, from KWS, handmade, no AI involved. And we also have an official logo that's on some of the other bottles. And so thanks for KWS for sponsoring the ingredients, the cost for the ingredients, and I would say help yourselves with the beer. It's in the room opposite of this hall. And thank you, Stefan. One remark, please pour it into glass.